Welcome to the frontier of kinetic architecture, the Pegasus Project. A 10-story flight simulator suspended over a 600-meter drop. This is not just a building. It is a 450-ton aerodynamic marvel.
Designed to withstand 180 kilometers per hour gusts while mimicking true flight.
At its heart lies a triaxial hydraulic motion system.
The ultimate fusion of high-stakes aviation and luxury living.
With a wingspan exceeding that of a Boeing 737.
Tonight, we deconstruct the engineering of the impossible.
From raw cliffside to the world's first winged residence.
This is Builds from Imagination, the Pegasus Flight Simulator.
Phase 1 begins with securing the 30-meter anchor bolts. Each pile is 500 millimeters in diameter, coated in anti-corrosive epoxy. Seismic dampers are integrated to absorb 95% of cliff vibrations. The primary cantilever must support a 120-ton dead load. Precision is vital. The center of gravity is offset by 4 meters. Technical challenge: unexpected fissures found in the granite. Solution: 5,000 liters of industrial resin injected to solidify the rock.
Alloys. The base cuts my price, and the base utilizes aerospace-grade 7075 aluminum alloys.
Automated welding ensures 100% structural integrity at every joint. A 2-meter thick hydraulic pillar becomes the main rotation axis.
High-pressure lines must handle 4,000 psi of operating pressure.
Floors are made of 15-millimeter aluminum honeycomb for weight reduction. The first of 24 kinetic ribs is now in position. Each wing joint features dual-stage electromagnetic actuators. Even at full extension, the wingtips support a 5-ton load. The frame must remain stable during 30 meters per second wind speeds.
The Moog Style 6 degree of freedom base is calibrated.
1,200 sensors monitor real-time stress on the carbon fiber.
Symmetry is essential for aerodynamic balance during rotation.
Technical challenge: harmonic resonance causing unsafe oscillation. Solution: a 10-ton water-based mass damper at the rear base.
UHPC provides a compressive strength of 150 megapascals.
The main bearings are ceramic coated for zero friction motion.
The brain uses a redundant triple-layered AI architecture.
The cockpit is isolated from the main frame by rubber mounts.
The feathers are actually 3,500 individual kinetic tiles.
Each tile tilts 30 degrees to manage wind load distribution. Construction phase 1 is complete. The Pegasus,
a majestic Arabian horse with impressive... Now, we wrap this titan in a skin of glass and tech. Phase 2, installing the 12-meter double-tinted smart glass.
The glass provides a thermal conductivity U value of 1.1. Electrochromic layers allow the glass to tint in 0.5 seconds. Every joint is pressurized to ensure a 100% airtight seal. A PTFT-coated membrane covers the wing for flexibility.
Technical challenge. High shear stress tearing the wing skin.
Solution, integrating a Kevlar 29 mesh for 5 times tensile strength.
The roof is covered in thin film PV cells for 50 kilowatt output.
The simulator walls are lined with 1.2 millimeter pitch LED screens. A 16K resolution provides total visual immersion.
Redundant HVAC systems maintain a constant 22 degrees Celsius.
20 kilometers of fiber optics connect the sensors to the CPU.
Each scale is individually addressable via DMX controls.
The first wing flap test. Power draw, 250 kilowatts.
Triple stage pistons provide a smooth 2-meter stroke.
Inside the horizon shifts perfectly with the wing motion.
The shell is complete. 8,000 square feet of glazing. Copper lightning rods safeguard the electronics from strikes. The Pegasus begins to breathe as the power grid goes live.
Technical challenge, hydraulic fluid temperature exceeding 90 degrees.
Solution, a closed-loop liquid nitrogen cooling system. In storm mode, the wings fold into the cliff for safety. A 10-meter retractable bridge provides the only access.
Once the bridge pulls back, you are officially airborne.
10-millimeter thick Italian statuario marble slabs are bonded down.
The reflection enhances the feeling of floating in the clouds.
Phase 3, the luxury reveal. The pilot's command station.
Gold-plated haptic switches provide tactile flight control.
A full-service bar featuring carbon fiber cabinetry.
Sofas are magnetically levitated to prevent motion sickness.
Every surface is covered in hand-stitched Alcantara suede.
The master bed is gyro-stabilized to remain level at all times.
Privacy at 2,000 feet.
The glass reacts to your presence.
Circadian lighting mimics the natural transition of the sun.
Technical challenge, 85 decibel noise from the machinery.
Solution, acoustic metamaterial panels to cancel out noise.
The carbon fiber is finished with a UV-resistant clear coat.
Gold leaf talons act as decorative structural supports. The Pegasus flight simulator is now fully operational.
Initiating full flight sequence. All systems green.
The 450-ton structure begins its graceful 4-meter oscillation.
The main pillar rotates to track the setting sun.
The immersion is total. Your mind believes you are soaring.
Real-world flight data is synced to the simulator's motion.
A masterpiece of engineering that defies gravity and logic.
Each of the 3,500 scales pulses with a biomimetic light.
The ultimate retreat for those who dream of the sky.
As night falls, the Pegasus returns to its cliffside perch. Total energy consumption is offset by the integrated solar skin.
Standing 60 meters above the crashing Atlantic waves.
Architecture that communicates with its environment.
Switching from simulation to the reality of the night sky.
A testament to what happens when we build from imagination.
From 30-meter anchors to a 45-meter kinetic wingspan.
The Pegasus Flight Simulator, where the Earth meets the sky. Subscribe to see the next impossible structure come to life. What should we build next? The sky is no longer the limit.